I hope you are doing well. Now it's time to do well in our studies. So in the last class we discussed about how we feel some extra weight while traveling in the lift and going to upper floors, and while going to lower floors we feel lightness in our body. So we calculated some equations and found that why this happens. So from the last equation and last case in previous lecture, we found that when the lift is traveling downward with an acceleration a, then the total effective acceleration, or the acceleration felt by the observer in the lift, will be equal to g minus a, right? Let us suppose the acceleration is this a is g. Then what will happen? The g minus g equals to 0. Then the net force will be equals to 0. So when this scene is called free fall, like let us suppose this chalk is falling freely, what we call is free fall. For me, the chalk is accelerating downward with an acceleration g, but chalk will say that no, I am not accelerating. Then I'll say that no, see, total downward force mg is acting downward, and hence you have and because you have some force being acted upon you, there is acceleration and you are accelerating. So your frame of reference is accelerating, you are in a non-inertial frame. But the chalk will say that no, see, from my point of view, I am at rest, you are accelerating upward, I am not accelerating downward. I will say that I proved my point by saying that a downward force is acting on you. You prove that no net force is acting upon you. Then the chalk will say that a downward force, which is a real force, is being acted upon me, which is mg, but a upward force or a pseudo force is also being acted upon me, which equates the value of downward force and equals to mg, and therefore the total force is 0 and I am at rest, right? This is the point of view of this chalk, or a non-inertial point of view of a non-inertial frame. So this is what we studied in the last class, and obviously now we are talking about inertial non-inertial frame where there is an acceleration. Suppose the case is that the lift is at rest, or it is traveling with a velocity, with a constant velocity, then we are not going to discuss about it, because there will be no pseudo force, or it will be equal to a inertial frame of reference, because when there is a acceleration in the frame, we will consider it as non-inertial. But a frame which is traveling with a constant velocity or at rest is an inertial frame. So what to talk about this, there is no pseudo force, and the actual force will be the force that this person will feel, will be the actual force, which we can calculate from the equations. So now we are going to talk about centrifugal force. Let me erase all this. What is centrifugal force? We know about centripetal force, right? We all have played that game in which we tie our toy with a string and just rotate it. So in that game, let us suppose we have tied our ball with a string. The string will obviously pull the ball with tension T. Then we will observe that a tension T force is acting inward, which will be called as centripetal force. Centripetal force is this tension force. So obviously the ball is accelerating, its direction is changing, so there should be a force which should change its direction. So this force is centripetal force, right? So the ball will say that no, I am not accelerating, I am at rest, just like this chalk. So now I will say that no, you are accelerating because the tension force is being acted upon you, which is a centripetal force. You are accelerating, your direction is changing continuously. The ball will say that wait, a centripetal force is being acted upon me, but the equal amount of centrifugal or a pseudo force is also being acted upon me. Hence my total force being acted upon me is 0, and hence my acceleration is 0, and I am at rest, right? So it is a non-inertial frame, and therefore this centrifugal force is also being acted upon this particle. So we are going to use our reference frames, non-inertial, inertial reference frame, and calculate the amount of this centrifugal force. So this let us suppose a coordinate system or a reference frame. This is a inertial reference frame S, which is at rest, and initially the ball is at this position, and we will consider another reference frame which is S dash, which is accelerating with the ball. Like every time the ball is at this position of this reference frame, so ball in this reference frame will say that I am at constant, I am at rest, right? But for this someone or something at this inertial frame will say that no, the ball is accelerating. Everything, this feeling of being at rest or not accelerating is like every time you are in some issues, you always feel like I am right, just like this ball. But the reality is like sometimes we are at rest actually, but sometimes our point of view only says that we are at rest, means only our point of view says that we are right. So it is to be considered from different point of view that we are actually correct or not, just like we are actually at rest or not. For this it is saying that I am not accelerating. From this frame it is seen that the ball is accelerating. So as the ball is accelerating with this frame, we will calculate the force on it from this frame, which is a non-inertial frame, which will be equal to F dash. F dash, from the formula we derived in the previous class, we found that F dash equals to F plus S pseudo force. The actual force, which force can be seen from this inertial frame of reference, and a pseudo force which will be acted upon the ball due to its acceleration. So what is the value of F dash? Actually a centripetal force is being acted upon it, which is m omega square r. We know the value of centripetal force, mv square by r or m omega square by r is pseudo force. We are going to calculate the pseudo force, and the ball is saying no force is being acted upon me, I am at rest, so F dash equals to 0. So now the pseudo force or the centrifugal force has the value minus m omega square r. We can also see from this diagram it is opposite to the centripetal force and has the same magnitude as centripetal force. So this is what is we call centrifugal force. Now we are going to do some numericals. So I will dictate questions, you will write it, and then we will solve it. So this is the book I am using to make these lectures and notes, which will be provided in the Telegram. So I will recommend you to read this book instead of reading someone else's notes. Although I have made these notes freshly for lectures. So question is, calculate the effective weight of an astronaut ordinarily weighing 60 kg when his rocket moves vertically upward and in the second case moves downward with 6g acceleration. So here it is saying that the astronaut in the rocket in first case is accelerating upward and in second case is accelerating downward with 6g acceleration, and here the weight of the astronaut is 60 kg. So we are going to calculate its effective weight, means the weight means the force from this frame. So in the first case it is accelerating upward. We can use the equation f dash equals to f plus f naught. Here we are going to find f dash. F will be equal to 6 kg into g, that is mg, gravitation acceleration due to gravity, and f naught a pseudo force which will act in opposite direction to the actual acceleration, that is minus m a naught. We know about all this, but we also know the equation a dash equals to a plus a naught or minus a naught according to our equation, that not our equation, our convention, where we put a negative sign or a positive sign. So instead of first completely using these equations, I will say that first we will calculate acceleration in both the cases and then just multiply mass and we will get the answer. You can use these steps. I will give you this work as homework, but I am going to use this equation and first find the acceleration and then just multiply the mass, get the answer. In first case it is accelerating upward with 6g acceleration, so a pseudo force will act downward with 6g acceleration, and obviously the acceleration due to gravity is downward with g. So total acceleration is 7g, but it is downward. We will consider a unit vector n cap directing upward, so its direction will be minus n cap, right? In the second case, the rocket is accelerating downward. A upward pseudo force will act of 6g into mass, and hence the acceleration is 6g, and a downward acceleration g. So total acceleration will be 5g n cap, which is upward. So now we are going to calculate the force. Force will be equals to mass into acceleration. Mass is 60 kg, acceleration is 7g. So net force will be, net effective weight or force will be equals to 4 minus 420 g n cap equals to, and here it will be equals to 5 6 30 300 g n cap. The net the force, the effective weight will be here acting upward and here downward, means while in this case the lift was going upward, so a net negative force minus means a force feel like where a force is being acted upon us in downward direction, so we will feel like being compressed. But in the second case it is accelerating downward, and hence we will feel like the force, net force will be upward, and we will feel like we are light now. So here are the answers. Second question is, a 1 kg stone at the end of a 2-meter long string makes 5 revolutions per second. Calculate the force on the stone as measured in an inertial frame and in a frame which is rotating with the string. So the question is that a stone of 1 kg is attached to a 2-meter long string, makes 5 revolutions per second, and measure its force on the stone from an inertial frame and in a frame which is rotating with the string. The from a frame which is rotating with the string means this frame which was in the previous case was S dash. We'll obviously say that the ball is not accelerating, and hence the total force will be equals to 0. But for the case which is a inertial frame, which is s in the previous case, will have some value, because in this case there is no pseudo force. In the case of frame of reference rotating with the ball, there is a pseudo force, so net force is 0. But in case of this inertial frame, the net force will not be 0. A centripetal force will be there. So to calculate this centripetal force, we have the formula m omega square r. Here m is given 1 kg, I guess, and r is given. We just have to calculate the omega. It makes 5 revolutions per second, means 5 times. In 5 times, just rotating in this path. So means in 1 revolution it will cover 2 pi. In 5 revolutions it will cover 5 into 2 pi angular displacement. So the total omega will be 2 pi by 5 equals to 10 pi per second. Per second it will cover 10 pi angular displacement. So now we will put the value. M is equals to 1, R equals to 2, omega square will be 100 into 3.14 into 3.14. You just calculate it by yourself. So with this we will end the lecture, and in the next lecture we will talk about how we feel a pseudo force like Coriolis force in a rotating frame like that of our earth. So till then, keep studying. Thanks for watching.